this is the part of the presentation when I usually photograph the audience, but I'm going to issue you with a warning. What we're going to review here is how to legally audit or search for vulnerabilities in web applications, that you have written permission to do those kind of things. So make sure you do get permission in writing. Maybe some of you are familiar with Randall Schwartz. Nice guys, finished last, and with 3 counts of felony. So check out the link in his legal case years ago, working for a small company called Intel, and he got in trouble for doing some sysadmin stuff on boxes that technically weren't his. So you've been warned because you don't want to go to jail.
No, sir, please. I can't go to prison. They pee in a cup and throw it on you. I saw it in a movie.
All right. The following presentation is based on actual case studies, actual vulnerability assessments that I've done over the last whatever number of years since early '96. So these are true stories. They're not fiction.
You want answers? I think I'm entitled. You want answers? I want the truth. You can't handle the truth.
All right, last sound effect for quite some time, so you can relax. So you're about to see, the point of pointing out that they're real is that if these folks made these problems, maybe your corporation could be having the same problems. And we're talking the big boys. I've been fortunate enough to be in the right place at the right time to do some assessments for, I refer to one of them as Big Bank. Under NDA, I can't say who it is, but very large banks, global banking, business-to-business banking, online reservation systems, 401k programs. You've named it, I've seen it. So I've taken some of the vulnerabilities that I've discovered and I've sort of put them in here, changed it around so you can't tell who it is, and make it more interesting. All right, so why are we here? We're going to talk about various web-based vulnerabilities, web application vulnerabilities, and the tools and methods needed in order to locate them and identify them. What we're not going to talk about is comprehensive methodology. I believe I'm speaking at Use next Tuesday on a full day on this, so come on down and check that out. But otherwise, we're just going to skim through it real quick and hit the high points and show you some examples. We're not going to cover all tools. My apologies in advance if your tool didn't make it in the presentation and you think the ones I'm demoing are not as cool. Sorry. And we're not going to talk about solutions, although part of the solution to any problem is to know you have a problem, right? That's always the first step. So that's about as far as we're going to cover it, is awareness. A little bit about me. Any Penn Staters? Woo, I'm the only one. Okay. Alrighty then. I started my illustrious career at a little-known company known as Bellcore. Perhaps some of you know them because you're on their networks years ago as a phone phreaker. Bell Communications Research. And now I'm working for Maven. And that's me on the right.
Wow, that's a great story. I'd love to hear the end of it sometime. Bye-bye.
All right. Here's the agenda. We're going to very, very briefly define the problem. I think we know what the problem is. And then we'll get into a tool set, kind of build up a set of tools that cover the key functionality required to look at the security of a web-based application. And then very quickly, we'll try to move through that. There's a lot of reference material, stuff I'm not going to cover in detail, but it'll serve as a good reference later when you download these slides off of the DEF CON site or off of our site. Once we have our tool set, we're going to take a look at some various points of attack, points of weakness within a web-based application, and then we'll start pulling out the tools and going to town and doing some demos. And then finally, after I point out all the various problems, we'll give a list of resources of where you can go and download best practices, how to code, how to filter user input, all that good stuff, how to secure your web-based applications. So I won't leave you hanging, give you some resources for further research. All right, what is the problem? Can't we just all get along? No. No, we can't. Websites are getting hacked for all various different reasons. Perhaps some sort of genetic deficiency, or not deficiency, enhancement. Sorry. But regardless of the reason, the bottom line is sites are getting hacked, and there's lots of great sites out there that show you the defacements like ZoneH, and we're not just talking about websites being scribbled on. In a lot of cases, we're talking about applications that have been exploited. And in fact, I have here captured some of the latest headlines under Security Tracker because they have a category for applications. And so you can zoom in here and take a look at all these web-based applications. Most of them are web-based, and they show you how various things can be exploited right through the comfort of your own browser. And here's a nice one here, further down, where you can do command injection. But just by modifying the URL, we're going to see some attacks like that. Only we won't be able to put it into the URL. We'll have to do it through a cookie. And again, real examples. All right, so the bottom line is somebody's going to be flipping burgers because the website got hacked. That's the problem. Web apps are getting hacked. Very big problem, and it's only going to get worse as everything's being webified. Old database or mainframe apps are now webified. The military, I've seen articles, the military is talking about webified weapon systems. Yeah, we're going to need you to not do that. Yeah, especially when you see the examples that I do have. So that's probably the biggest thing that worries me. Here are the essential techniques that we need for our toolkit. We need to be able to intercept and manipulate raw hypertext transfer protocol. That's the stuff going between the browser and the server. And we also would like the ability to mirror a website. And I'll cover that briefly, but I don't have any demos for that. Also, we want to automate fake browser requests, brute forcing, not just authentication either. Brute forcing various elements. Some folks call it fuzzing. And I'll show you some stuff for that. And then finally in your toolkit, one of the more important things is to be able to decompile Java applets. And so that's what we're going to very quickly build a toolkit and then move on to see it in action. The first and foremost thing is to be able to intercept and manipulate your traffic. Why do you want to do this? Well, you can bypass all sorts of client-side restrictions. Way back in the day, people thought you could, filter user input by using client-side JavaScript. That doesn't really work when the person owns the system, the client-side system, and they can bypass all that. Want to be able to maybe violate the HTTP protocol by adding in headers that are too large and things like that. Maybe insert alternate choices in the pull-down menu, or pretty much just change any portion of the traffic, and we'll see several examples of that today. And also, not to be forgotten, it's very important if you're intercepting your traffic, you want to record it. Later on, you'll be able to search through it for various things like hidden comments within the HTML. All right, so let's cover a little bit of history. This is old news, but Achilles was the world's first publicly released general-purpose web application security assessment tool. Anybody heard of it? Yeah, okay. So that was a little idea I came up with a couple years back. I was actually using something similar, only less stable. And if you can imagine anything being less stable than Achilles, there you go. And so I got with my friend Roberto, and he just coded it up real fast and threw it out on the net. And my apologies. So it was released in October 2000. Shortly after this was released, Rainforest Puppy came out with something, and then the folks at Stake came out with something, and a couple other people, and now there's a whole bunch, and they're all vastly superior. I included in here for historical purposes. So what was it, and what are the others like as well? It's like a matrix-style web proxy. You can freeze frame your traffic and be able to manipulate it and then send it on its way. And the really nice thing about Achilles is that you can modify traffic in either direction. And you can also modify SSL traffic. Doesn't matter. Encryption does not protect your website, okay? I know the vendors like to say it's secure HTTP. No, it's private HTTP in transit, but it doesn't really secure your website from buffer overflows and all sorts of manipulation. And again, apologies, Achilles only runs under Windows, but you can force it to run it under Unix with Wine. But it's basically a big kludge, and just like Notepad with an attitude. And this is kind of what it looks like. You can intercept your traffic and modify it, and I'll give you a little demo of that later on. But here we see a request coming, actually a reply coming back from a web server. And they're trying to set a cookie for us, and this is our opportunity to modify the cookie once and for all before it gets into our memory. Most other tools that are in this category will let you modify it on the way out. So you have to modify it every time. This is a nice way to modify once and for all without without having to repeat it over and over. So this is how it works with SSL. You have a web browser talking to Achilles. Achilles acts like a web browser when it talks to the server, but when the real web browser talks to Achilles, it acts like a server, web server. So when it comes to breaking SSL, it creates two SSL sessions, and so now your browser will warn you, hey, the digital certificate from Yahoo is signed by somebody named DaSquid, and it's not VeriSign. DaSquid is Rob's old Navy nickname, so it has a little certificate and everything, and so it does man in the middle, but it obviously doesn't break crypto. If it broke SSL, it would have made more headlines, so no. But for auditing purposes, it does the job.
I see everything.
So just a real quick demo then, and then I promise we will move on to vastly superior tools. But is there any work being done on Achilles? No. There might be if you request it nicely, but he doesn't seem interested. I tried to explain to him how important this really was when it came out, because it was the first. Will he give out the source? Probably not, but I know a couple people that came up to me and said they reversed it and that the code was really poorly written. And I was like, where do you work? And they're like, oh, crank call, and they walk away. I think he was working for IBM actually, but so no, I don't have the source either. And that's the problem with coming up with a great idea and then having someone else code it. Is they control the source, they can do whatever they want. So I'll put a request in. I think it's time for a new version, maybe something that doesn't crash every 5 minutes. And so let me give you a quick demo. So you just configure your browser real quick to use a proxy. Many of you probably use a proxy at work to get out. Well, you just change it to this proxy, which is, you can run it on localhost, you can run it on another box and connect. And once it's running, you can intercept your traffic, and here it is. And so you can go ahead, let me zoom in real quick before it crashes. You can see what I'm about to send and send it on its way. Now the interesting part comes in when you go to modify traffic. Let me go ahead and modify something real quick. You can turn off the point and click. You can just have it flow through uninterrupted for a while if you're tired of always going over and clicking it. So let me go ahead and show you this. So we zoom in here, and I can go ahead and bypass any client-side restrictions and add a whole bunch of 4,000 digits for the PIN. Achilles will go ahead and take the content length and rewrite it for you to the proper amount, which at the time it came out was a big relief for me because back in my day, we were sitting there having to do that manually. And so nothing terrible happens, but we'll get back to this application called Buggy Bank later with some more sophisticated tools that'll automatically go in and manipulate things for us. But I'm going to go ahead and turn off Achilles so I don't accidentally surf through it later. And, it's like the Model T. It's nice in a museum, but I wouldn't want to go off-roading in it. All right. It modifies traffic in both directions. So when you tell your buddy, hey, we got a new web proxy for the company, so you got to surf through this. And when they're surfing the website, you can change things on the inbound. So now new tapes emerge on U.S. Hunt's Dark Tangent. So, you could modify it and modify things on the way in and stupid party tricks. I'm not sure what good that is for security, although social engineering. All right, so what are some of the better tools out there? My vote goes to Web Proxy by @stake. Version 1 was free. It's still online somewhere. If you look hard enough, it's Java-based. It'll run on anything that runs Java. Version 2 is commercial. I don't know the functionality difference. And then if you're really hardcore, you want to use the Spike proxy. Just some more references for you when you download the slides. Lots of good tools out there that are like Achilles, only stable. And finally, there are some tools that are more like browser replacements and or extensions to the browser, and we'll see some of these. They put functionality in your browser. So now, it's extremely easy to manipulate hidden form elements. And just to also want to mention these other toolkits are out there. These are more all-purpose. They don't just simply intercept and let you modify something. They do more than that. They'll maybe crawl the website for you. They'll automatically modify things for you. Very powerful. And so check those out as well. So a little bit more, let's take a little closer look at Web Proxy by @stake. What happens is once you start it up and it's your browser's configured to use it, all you have to do then is surf to a special, actually I already have it open, you just surf to the special keyword Web Proxy and the interface pops up. I kind of like that, some people don't, but you can go in here and you can create intercepts. And what an intercept is, you tell it, look, whenever you see this string, and it's 4 eyes. I just picked I because it reminds me of the word intercept. 4 eyes, when you see that going out, I want you to freeze the traffic matrix style and let me change it. And that'll come in very handy when we want to start manipulating our cookies and things like that. And we'll talk about that when we get to the actual attacking portion. But for now, this is just a toolbox. One of the more powerful features is the fuzz feature. It allows you to go in and say, for example, let's go to this and I created an intercept of 4F. So when it sees my pin was equal to FFFF, it pops up this interface that says, hey, what do you want to change? And I zoomed in here and I say, well, oh, look, there's a hidden form element called transaction. Why don't we go ahead and automatically kind of hack through a whole bunch of choices for that? And it has a list, user-definable list of things it'll try. It'll try various SQL injection, cross-site scripting, whatever you want. You can put into a text file, it will try. The text file it comes with, known as fuzz strings, is kind of limited, so you want to add some of your own. And I'll tell you where to get some. One of them is from there's a Nessus plugin that actually does some fuzzing as well. You can just look at the source and you can see the various things they're trying. So we're done. Here's what it did. It actually went through and it sort of brute forced that one form element. And it tried all of these things. It tried a 0. It tried a -1. It tried some special characters. It tried some file name stuff. And it apparently was successful or found something down here. And it turns out that that's cross-site scripting. If you would go in here and look and analyze it a little bit, you would see that it's cross-site scripting. But we won't do that right now. Just wanted to show you that it has the ability to automatically go through and hack. Now, there's some vendors who sell tools that do this for lots of money. This one's free. Or the commercial version of @stake is only like $995. There you go. You buy 2, right? That's cheap compared to the other tools that are out there. And some of those other vendors use phrases like robo-hacking technology. It's a for loop, man. It's just going and it's just repeating through. Or artificial intelligence. Say, listen, if a vendor ever tells you their product has artificial intelligence, they're referring to their sales and marketing force, okay? Yeah. Right. Okay. Another nice feature about the @stake tool is it has a console, and you can see all the stuff flying by. And so this is your opportunity to see the headers and to notice when certain cookies come into play, things like that. And we've already seen that. How many folks have seen the FAQ? How many folks have seen the Web Proxy tool? Did you read the FAQ? It says, are there any undocumented features? Yes. And then it just moves on. And it doesn't. Does anyone know what those undocumented features are? Anybody? We'll see here. Okay, one guy. All right. If this is not the one you know about, we got to talk. So this is worth the price of admission right here. Let me tell you about one of the features it has. Never mind how I know this. Crank call. Okay. It can be a transparent proxy. And what that allows you to do is if you're forced to absolutely go through a proxy because the application insists on it, well, then what you need is a proxy in the middle between you and the official proxy that's invisible, transparent. And that's what a transparent proxy will allow you to do. The official proxy won't know that you're using yet another proxy. So how you do it is you would just add that line into the config file when you start it up. And I hope nobody's mad that I revealed that, but hey, they're the ones with the FAQ teasing you, practically begging you to investigate further. So there you go. How or why that would be useful in real auditing situations is left as an exercise to the viewer. But it is useful. And then finally, IE Booster. This has got to be ridiculously easy to use. My grandmother can now start like manipulating hidden form elements. And come to think of it, she really did get a good deal on that plasma TV, right? She's shopping online, and we see there's 2 form elements that's asking for our account name, and it's asking for a password. But we just right-click. Now, I'm sorry, this is only for IE. So, folks out there with Mozilla, send me the URL if you know there's an extension like this. I'm sure there is. There's new extensions added to your right-click menu, to your context menu, and one of them is show all the forms and the applets. And so that's kind of nice because then you click on that, and it shows you there's a hidden form element. And oh, look, it's in a little text box in case you want to modify it. Nice. And so we go in and we can modify that and just send it on its way. Look, Mom, no skill. Right? That's pretty scary. That's one you show to your boss to get their attention when they say, oh, well, it's all complicated or something. Just show them that one. They'll even be able to use it, probably. Another technique within our toolkit is a brute force, specifically brute forcing authentication. And Brutus is one of my used to be one of my favorites. It's GUI based on Windows, and it will brute force web based authentication. It does.
What kind of music do you usually have here?
Oh, we got both kinds. We got country and western.
So it does both kinds. It does basic authentication and form based, and so it also does a lot of other protocols. Pretty much any text based protocol. Brutus, you can write a script in Brutus very easily with a GUI, click and drag type thing to build a script to brute force any kind of custom clear text protocol that you want to brute force. So it's nice in that respect. It's great for the command line challenged. And one of the really nice features is it has this. When it comes time to brute forcing a password, you can load in a dictionary file, or you can let it build a word list on the fly. So no longer do you have to sit around with a text file of all possible 6-digit numbers. You can just build it on the fly. Save yourself some disk space. Less forensics evidence, too. I mean, all right, so... What? It also has a permutator built in as well. It'll turn your password dictionary file into elite speak or whatever by making the fives, S's into fives and all that good stuff. Very handy tool, but the one I'm going to demo is www.hack later on. But a point of interest, these are other authentication brute forcing tools, is Screaming Cobra was interesting historically speaking, because it would crawl your website, find all the forms with form elements, hidden or otherwise, and would automatically fuzz them. So, but it's not being updated. It doesn't support SSL, but it's a Perl script, I believe, so it's open source. And you can go ahead and change that. And also, Nessus has a plugin that'll brute force CGI parameters. There's a nice little list of things to try or things to add to your other fuzz programs. And finally, some more references on where to get word lists and tools that'll build variations. That is, to permutate the word to make the O's into zeros and things like that. I think the last thing in our toolkit, next to last, is we want to decompile applets. Java is compiled into bytecode, but that can be decompiled. Where are you going to get an applet from? Some applications use client-side code. They send you an applet. If you've ever used IBM's Host on Demand, oh man, that thing's a mess. It sends you all these applets, and it's like a web front end to old mainframe applications. Yeah, that's what we want to do. We want to webify our mainframes. We want to put rollerblades on a dinosaur. Yeah, somebody's going to get hurt. All right, this thing was not meant to have that many concurrent users and all that good stuff. So anyway, that's where I stand on that. And so you have client-side code. You can also maybe steal the applets from the server because of server-side weaknesses. The web server's misconfigured, and you can retrieve any file. So what file are you going to pull? pull their source code, decompile it, and there you go. And then, of course, a lot of applications, like web proxy, are being distributed as Java, so you could, within the bounds of the law, decompile them and start doing all sorts of stuff and reverse engineer them. Not that I'm saying you should. And they may contain sensitive information. Why would you want to do that? Well, we have seen during audits applets which have hardwired credentials, because they think, well, it's compiled, even though the applet's on the client side. It's, it's hardwired in, and it's using encryption, so nobody will be able to see it. And it's compiled, so nobody will be able to see it. But you can actually pull it out, and or secret URLs, and or undocumented features, and things like that. And there's some tools for decompiling Java. Finally, last tool you probably want in your toolkit is something that'll crawl and mirror a website. The theory behind this is you could go out through a whole bunch of websites, pull down the HTML that they're willing to serve to you, and then search through them for inappropriate things like hidden comments, the meta generator tag. It'll tell you if they're using front page or not, and or you also want to try to find a mirroring package that will record the HTTP headers. My preferred method when doing assessments is to fire up one of these proxies and put it into recording mode and just let it dump everything to a file, then pull out a command line with grep, search tool, and then just go to town. And so that's probably the preferred way. I don't know that I would let some automated thing go through my web app and start pounding away, but their entire product's based on that theory, so I have to be careful. And here's some headers we've seen. The ex-Bender header. Care to contribute to the anti-mugging you fund? Bender, as in Futurama. Who knows where these headers are coming from? Slash dot. If you go to slashdot.org website, use one of these proxies and take a look at the traffic. They throw in the Bender headers for whatever reason. And then occasionally the ex-Fry header as well. And there's some tools for you. We're not going to do any demos for that. So now we have our little toolkit. Let's get busy. And these are the main points of attack we want to look at today. This by no means is all of it, but this covers really some of the core essential problems with web-based applications that are worth investigating. So first up is authentication. No surprise here, you can brute force stuff. So I'll give a real quick demo only because I want to make sure everyone's aware that there are tools. Yeah, sure, you can phone home. So this tool is ET is phoning home and trying to contact like a porn ad server. So I'm not sure you might consider that a feature, or I'm not sure. But anyway, since I'm not on any network that I'm aware of, it should be safe. I want to make sure you realize that these tools are now dirt simple. So let me see if I can find a login for it to brute force. Here's one. We'll go here, go to the login page, bring up the tool. It brute forces various protocols, but the one we're interested in is HTTP form-based, right? So we'll click on that, and automatically, out of memory, it knows that I have a browser open with this URL. So it's just like, hey, is that the URL you want to brute force? It's very friendly. Now, let's go back. Let me go back here. Let's right-click this and take a look at the underlying structure with. Wow, what a mess! This has got a lot of hidden form elements. This script will discern through artificial intelligence how to brute force this particular form. It will know through a simple search, I'm sure, that the form element called username is probably the username, and the one called password is probably the password. So they have real simple, obvious names. So when you click the auto magic artificial robo button, all right, now I'm being mean. Boom, it fills in. Username field is username and password field is password. And it has a little database of, PIN or PASS for password or PWD or things like that. And then all of the rest it just kind of shoves on the command line or on the URL. So That's all it takes for this tool to learn and be able to brute force any generic form. Sweet. You give it a string that is always found when authentication fails. Very subtle but useful feature. You teach it what a failure is, because we all can find out what the failure is. You just go to a website. If you're doing a blind pen test where they won't give you test accounts, you fail the login. Anybody can fail a login. It's easy. And it returns a string like return to calendar. So if we continue to brute force and we no longer see that string, maybe, just maybe, we got in. And now I've lost my tool here. Where is it? Okay. Uh-oh, now I broke it. There we go. So we tell it to look for the string return to calendar. We got that, and you just hit go, and it does what it's got to do, and it keeps sending that particular request over and over until finally it says the username is Al Gore and the password is lockbox. Is that true? Really? Did it work? Sure, let's find out. I'm going to go ahead and close this tool down, at which point it yet again tries to phone home. All right, and we'll type in Al Gore, lockbox, and what do you know? It ain't kidding. It really worked. Whoop-de-doo. Whip-de-friggin-doo. You say, well, we can just lock our accounts, temporarily lock them, to slow that tool down, make it grind to a halt. Does that protect us? Sometimes. So this next one is kind of interesting. This was found in some online banking in Europe. I call it pin harvesting, because what you could do is lock an account and keep on brute forcing until eventually you could get the password, even though the account was locked. So first, let me tell you what username harvesting is. That's where you go to an app and you go to log in, and based on a failed login attempt, you can figure out what is valid and what is not valid. So if we type in gibberish, it says, hey, that's not a valid, there's no user by that name. But if you type in, Al Gore, it says bad password. So we have the ability to collect usernames, harvest usernames. That is not terribly significant unless the username is a private credential, like, and some banks do this, your bank card number, your 16-digit bank card number. And if you give error messages like that, you've now supplied an online bank card validator. Probably, it would be very useful to some people, but not to your customers. So that's username harvesting. Then what I discovered was password harvesting, where I'm doing this assessment, and it's a big bank, right? And I was doing their assessment in the U.S., and then a couple months later in Europe, and then finally in Asia. Asia was the worst, had the worst security. I'll show you that later. We could run commands on it. This one, we could in Europe, we could only basically get people's PIN numbers. When you lock your account, you get a message. And in German, that says roughly, unfortunately, this PIN is wrong. That's when you try the wrong PIN on a locked account. Eventually, your account's locked, you get the right PIN, the error message changed. That's just plain wrong. So I don't speak German, but I know how to see two text strings change. And so I'm up out of the chair doing my little, dance, and then I realized the bank auditor's right there next to me, and I was like, sir, you have a problem. Very interesting procedure. The bank always had somebody there right next to me. And I figured it out later. They said, we'll help facilitate if you need something, the web server's not responding. It was so that if I decided to retire early, I'd have to split the money. That's what it was. So, and all right, so finally, the last thing I think I'll put here for authentication is maybe you don't need to authenticate at all. So, for example, this calendar software that we have here, let's just back up to a public site here. We notice the name of the calendar is embedded as a form element. Calendar equals Vapor External. So what if we were to go to March 2000, and 2 and change that name. I'm going to go ahead and change that calendar name to the word private. No. We could brute force this with any of those point-and-click tools, and lo and behold, things start popping up because now we don't have to authenticate as long as you know the calendar name. And I'm sure many of you have seen applications like that where you can suddenly get in just because of a URL problem. We don't need no stinking password. All right. Authentication might not affect your application because you don't have authentication. Maybe it's an online shop. As long as you have a valid credit card number or someone's valid credit card number and a shipping address, they'll send you stuff. You don't need to authenticate. Well, then what would affect you in pretty much every other application is session tracking. This is where you don't have a constant TCP connection to the web server. You make a little connection, you request something, you make a request, they send you the reply, and you disconnect. And then the question is, from click to click, from submission to submission, how do they know you're the same you? How do they know you're the same person? They can't go by IP address because they're not unique. People use proxies and people are natted and stuff. And so you have lots of people appearing as a single IP address. And so what you need to do is you need a unique identifier embedded in the traffic called a session identifier or session ID. That is either usually in the cookie, it's a more popular way of doing it, or embedded in the URL. So the next time you're at Amazon, notice that every single URL on the page has the same big serial number on it. And so that session tracking, if I can figure out what your session tracking, what your session ID is, I can become you. It's a small window of opportunity. It's just while you're logged into the application, but still, it's viable attack method, especially since there are ways to get the session ID in real time from other users. So let's take a look at some of those attacks. You could predict it, and that's pretty easy. What you do is you just figure out when and where this application first gives you a session ID. And you would use a proxy tool and look for suddenly the URLs change and there's numbers in them, or there's a cookie. Let's for instance say it's a cookie. Figure out where you get that cookie, and then take that URL and then just request it over and over again with, I'll show you a nice little GUI tool again. Or, of course, if you're on the command line, you could just use curl. I'll show you that later. Collect a whole bunch, and then do highly sophisticated mathematical analysis known as subtraction, and then look for a pattern. So let's take a look at this. This is a nice little tool by iDefense. You guys here? iDefense? Okay. All right. So nice little GUI tool and very easy to use. And let's take a look at this. So what we can do is just use it to collect cookies. I happen to know for a fact that Buggy Bank issues a cookie right here. So I take that URL and I can just go ahead and collect them. And then I think I see a pattern. 136, 137, that's the Unix timestamp, the number of seconds since January 1st, 1970. So, yeah, not a terribly sophisticated session ID for this particular application, and but that's just a fake example. I can show you some real stuff. These are mock-up examples of past assessments. This was some credit union software. The numbers were much bigger and more random than this, but this was just a quick example I put together. And I'm looking at it and I say, well, as time goes by, time is increasing downward, the session ID is always getting bigger. That's not random. So let me do some highly sophisticated mathematics here. I'll take one cell and I minus out the one before it and I get the delta. And I say, okay, there's a delta between one cell and the other. It's 10,293. What about the next delta? Oh man, it's different. Oh, I guess I'm done. I'll just stop here. But wait, maybe I should just kind of keep going just in case. Uh-oh. Loser. Yes, true story. Is Alfredo in the audience? I called a coworker years ago. We were working on this together, and I called him up and said, "Hey, log in and view cookies, and tell me when you logged in." And he logged in. He goes, "Okay, I'm looking at it." I said, "Dude, is your session ID 729-473-2879404-296?" "How'd you know?" "I know Kung Fu." Right. Until I told him, and then he was like, But even still, even if it's a little bit more complicated, this is a reasonable simulation of a recent assessment I did for us. Recreational facilities, online reservation system. You go online, make ski reservations and stuff like that. And that looks better, right? That looks more random. Some numbers are getting bigger and some are getting smaller. Sometimes it gets smaller. And you can really start getting freaky with this analysis. I told my wife, I said, I made her watch A Beautiful Mind. I said, look, those are the signs to look for. If you see me in front of my computer, woo, and the patterns are starting to pop out. No, I'm serious. I look back at some of the reports I've written, and I spent just a little too much time analyzing. But I was successful in attacking systems like this. And when I say attacking, I mean auditing with permission. I do. I get paid good money. So, look, suddenly it's not so random. The delta starts to smooth out. So it's not totally unpredictable. And so there was an application like this recently, and I was able to figure it out. And basically there were groups of digits, and some of the digits were very predictable, other ones, and eventually was able to pick up other people's session IDs. So, maybe you don't have to predict it. Maybe you could just brute force through the total space of possible possible session IDs. And so the iDefense tool will allow you to brute force a session ID if it's in a URL. It claims to do the cookie as well, but there's a little coding flaw, and it doesn't work. So you'll have to wait for version 2, or you could just use curl. I think I'll show you that later. And so you can brute force a URL. This part does not work. If you want to know why, put a sniffer on the line and you'll see why. It's using the wrong headers. So what I can do is, we'll look at that in a moment. So for example, we take a look at Buggy Bank. Let's log in as Fred. And I'll view my account balance, and something I'll notice is there's something embedded in the URL. In every URL, after I authenticate, I see something called SID123. Now you might think this is a far-fetched example. This is probably one of the first assessments I ever did way back in the day, and they were using like a 3 or 4 digit session ID. I'll give them some credit. All these parameters were encrypted. It was just a matter of finding the old CGI script. They had the old version still on the server that would decrypt it for me. It's really convenient, So, and then once I saw that it was 3 digits and they were issued sequentially, I was able to work them backwards and pull out everybody's completed credit card application. And that's when one of my bosses was like, "Hey, could you sort through those and find single women with good credit ratings?" It's like, with no dependents? It's like, no, I cannot. But, and so to brute force that, you can go ahead and I just already worked out the syntax here. You would take that URL and put it into the brute force tool here. And it has a syntax where you tell it what digit to start on and what type of digit range to use. And the number 1 means 0 through 9. And that's all explained in a little info button here. Won't bore you with that. So bottom line is we want to go ahead and brute force that URL, changing that number, looking for the occurrence of the phrase your account balance, or account balances are. So that's the string we want to look for. Because if we just randomly guess a number, we're probably going to get an error message. Right. So then we'll just let this brute force. And it seems to stop at 133. And sure enough, you go in, you back up, and you type in that number, and it goes from Fred Bucket to, well, it's my account. And a very healthy account it is. Right. Okay, so now, I don't want you to think I'm, Mr. GUI tool or something, right? So I have to put in some little command line kung fu here. If you're doing any kind of work with web applications and you haven't tried curl, you need to try it today. All right? Don't delay. So here's an example of a command. You can embed your own cookies. You can embed your own post data. And then finally, the URL you want to attack. I mean, this is basically a command line browser, sort of. It only does a single request, and you get the response back. But because it's on the command line, you just wrap it in a Perl -E little script right on the command line, and you can start getting busy. So here's an example of where this would go out and grab our account balance. Not a big deal. However, if you iterate over the session value, or at least the last 3 digits of the session value, you can go back through and start finding other people's session IDs. And so, so that's left as an exercise to the reader. And so never underestimate the power of Perl and curl. 2 great tastes that taste great together. All right. Finally, maybe you can't brute force it. Maybe you can't predict it. What else is there to do? Steal it, right? And or as they say in London, you can pinch it, right? And so probably the easiest way to do that is through cross-site scripting. This is where you either trick someone into clicking a URL. That URL contains JavaScript. They send that JavaScript off to a website that reflects it back, and that person ends up hacking themselves. Or you embed it into a website. So imagine this little piece of JavaScript down here embedded in a website in like a forum or a news group. And then some poor unfortunate soul surfs to it, and suddenly what it will do is it will pop open a window and contact evil site on port 888 and embed all their cookies. So, for example, suppose this JavaScript was embedded in a news forum for Vaporware, the Vaporware Corporation. Anybody viewing that calendar entry that had this would send all their Vaporware cookies, which include the session tracking in many cases. So let's take a look at what that looks like. I'm going to go ahead and use my little cheat sheet here to bring up my command line. And I'm going to go ahead and start up everybody's favorite Netcat. Some people make a good living talking about nothing but Netcat. Hey, Ed. All right, so all right. So there we go. We're our evil hacker, who apparently has a very sunny disposition because it's a white background. Our evil hacker is listening on port 888 for some poor unsuspecting victim. And who would that victim be? Well, let's go ahead back to our bank and log in. Now, we know there's a user on here called Al Gore. So, of course, there's a user called George W. And how do you spell strategery? All right. Okay, good. All right. So then we got a real... You know what? I'm already logged in on this other... Well, I'm supposed to be. It's already logged in? No. So we'll go to a private calendar just for the company where other employees are posting things. I'll go there. I'll view that calendar. Switch to where I know the booby trap is, March 2002. And I see a little thing that says, "Hi, George." And so that looks enticing. I think I'll click on that. And watch carefully. What was that? I don't know. Probably just ignore that. Nothing to see here. What happened was a pop-up appeared, spoke to Evil Site, sending our cookies. Evil Site was nice enough to send a little piece of JavaScript that said, "Dear Mr. Pop-up window, you can close. You can close and hide all evidence of your existence." Now, when I did that recently for a customer, I went the extra step and I did a pop-under window. So they didn't see anything. And I was able to show them in a controlled fashion that I was able to take over other accounts. Here's our little happy hacker site. And we see that somebody connected with a browser request. Apparently George W. is using IE. That makes sense. And look, they sent their cookie. That's their session tracking mechanism for that user. So real time, grab the cookie. So cross-site scripting is most dangerous when it can be embedded into a website, because all the victims are already authenticated. And in real time, they're live, active, useful session IDs. That's the most dangerous. And then second would be someone being able to reflect it off your site, being of a slightly lesser concern. Okay. Wrapping up here with the last two sections, there's unexpected user input. We've all seen this. You can get SQL injection errors and various things like that. I want to show you one from Big Bank where they were using a cookie to encrypt account numbers. You would type in your account number, they would PGP encrypt it, give you back the cookie, you could store it. When you go back to the website to log in, rather than typing in your very large account number, you would send them automatically the cookie upon surfing there. They would dynamically decrypt it and put the last 4 digits in the HTML and give you a nice little drop-down box of all your cookies. It's kind of nice. I mean, of all your account numbers. So if you had like 5 accounts, you could choose which one of those accounts you want to log into. Just select it, type in your 4-digit PIN, and go. Very convenient. There's only a problem, though. That data was being passed to PGP. The data that was on your system and being sent to them. Now, you manipulate the cookie, and you get an error message about PGP. So, for example, if we go to Buggy Bank here and do a funds transfer. Whoops, I guess I'm not logged in as a legitimate user. It's been tampering. Let's see. And I define an intercept with web proxy, freeze it, go in here to my cookie, this cookie here, and add some garbage like a semicolon. I end up getting a very cryptic little message. You could almost overlook it. It's so small. PGP. So you start thinking about it. How are they getting my cookie data to PGP? Well, PGP is an encryption tool that works on a command line, and of course they're probably running it as root, right? It's run everything as root, and it always works. And so PGP cookie data. But if I control this, then I control the command line, don't I? Couldn't I put some junk in the cookie and then a semicolon followed by commands? No, that couldn't possibly work. And yeah, this was another one where I jumped up out of the chair and was dancing around, and then I turned around to the guy and said, "Sir, you have a problem." Did my little hacker dance, netstat space minus NA. I prefer netstat as my command injection of choice because it runs on both kinds, country and Western, Unix and Windows, same syntax. So now I'm running commands on one of the world's largest banks on their application server. And you haven't retired yet? No, so...
I've fallen, and I can't get up!
Yeah, so that was bad news for them. And finally, one last thing I want to cover real quick is an application flaw, application logic. This is where you try to do a transaction, and there's certain steps required, but you do them in the wrong order. Think about this. You want to transfer money from account A to account B. First, are you authorized to take money out of the account? Always an essential question. Are you authorized to put money into the other account because maybe it's not yours, or maybe it's a money market account and you're not allowed to put money into it but only so many times per year? Finally, last, once those first two are answered correctly, you say, do you have enough money? But this credit union software, so this affected lots of credit unions, was doing step C first. So the way that played out is you could, let me go back here, log in, super secret PIN, and do a funds transfer, and go ahead and do $5 and intercept it. Ooh, I'm out of time. That's okay. And I'm going to go ahead and change the from account to someone else's, and I'll try to steal $5, And it catches me, your pathetic attempt has been detected. Please assume the fetal position. The mafia boy maneuver. So, or whoever that kid was that dropped to the ground when they busted in his door, I'm sure I would have done the same. But now you think about it, what if they're checking the balance first? So instead of $5, I'm going to do $5 million. And what comes back now is an error message. What's the error message you give someone when they exceed their balance? Why, you give them the balance. So I now have the ability to collect balances on any account number. And correct me if I'm wrong, that was for credit union software, right? Or was that for one bank? Yeah, credit union software? Cold State, that's where it started? Okay. Yeah, okay. My ex-coworkers are in the back. And so, yeah, this was a nice little feature. Let me let's view this form. Let me grab my cookie. I'm going to grab my session ID, because then what I want to do is do some more. I wrote a little script just for you guys that would go through and it would go ahead and just take my current session ID. Notice we're not going to brute force session IDs or anything like this. We're going to take our session ID and yeah, I know. All right. It goes through and iterates through lots and lots of different account numbers, collecting balances along the way. Oh, but don't worry, the website's using SSL, so it's protected. I'm hacking in privacy. Thanks, VeriSign. All right, so in conclusion, brains and clues are not included. You have to know what you're looking for. Beware of robo-hacking devices. They're only going to crash your back-end databases, I assure you of that. And no one tool does it all yet.
I know Kung Fu.
You're eventually, if you really want to do the job right, you're going to have to show me. You're going to have to show me your Kung Fu with various things. I recommend Perl and Curl. And then, by all means, download WebMaven, a.k.a. Buggy Bank, and go hack yourself, okay? It's a fake app. It allows you to, practice legally and safely in the comfort of your own home. And various other resources are listed. I encourage you to check out the presentation slides by downloading.
One more question and I'm beating the shit out of it.
I'm sorry, were there any questions? No time for questions.
Where to download?
Where's the download?
Yeah.
The slides?
Yeah.
DEFCON.org, right? All the media's there. You're going to, or our website.
One more question and I'm beating the shit out of it.
All right, no more questions. Since you asked the question, you can have the speakers. That's the quickest way I can figure out how to do this. So, yeah, feel free to visit our website in a passive, non-hostile fashion and download the slides from there. Thank you.